Question number 1.
Possibly.
Maybe.
I did 1, -1, -1, 4.
Ah, okay. So, how did people go about doing number 1?
I looked it up.
You looked it up. What does that even mean?
There's this one website. It usually tells you how to do it, but it didn't tell me to do it. It told me the solution. So.
Okay. So you got an end result.
Yep.
How did you do it?
I typed it into the calculator, and then if you go to like the second tool, it shows you the zeros.
Oh, okay. So you use the table. Not a bad idea. Okay. Who else? What else did people do? Graphed it and just found where it crossed the x-axis. Okay, so basically nobody has any proof behind the answers that they
Well, I
have.
factored it too, so like I did the -1/4.
You got one with proof?
Yeah.
Which one?
I grouped I got -1/4.
Oh, okay, so you did the grouping method to factor this.
Yeah.
Ah, okay.
Yeah.
Let's start with that idea. Okay, so if I was going to do this by grouping, okay, you can group the first two and group the last two. And what's the greatest common factor out of the first quantity? Okay, excellent. I'll write you a note back. Okay, so, sorry, what was the greatest common factor of the first quantity? X squared. Okay, so I pull out x squared, and what's left over?
4x plus 1.
And the greatest common factor of the second quantity? -1. And, oh, it's not?
No.
1.
We put -1/4 and then factored that out. Or positive.
Oh.
Yeah.
Okay. Okay, so let's pretend that you did this. And now it can be like, okay, we did this right because the two quantities are the same, right? 4x plus 1 is one of our quantities that factor. What's the other one? X squared minus 1. Okay, and what do you notice about x squared minus 1? It's a difference of squares, so what does x squared minus 1 factor into? Good, so x plus 1, x minus 1. So now, once I have it fully factored, I can set each of those quantities equal to 0. And what are the three solutions that we end up with? So what do we get from 4x plus 1? -1/4. And what do we get from x plus 1? -1. And x minus 1? 1.
So does that work with the fourth, right? Because it's so.
Yes. Okay. So here's the thing. So the idea of 7-1 is we need to be able to solve polynomial equations. Okay, so we've done quadratics. Okay, we did quadratics by factoring. We used quadratic formula. We completed the square. We did it by graphing. Okay, and then we did graphing some polynomials. We did a couple trinomials. We did like a sum of cubes, difference of cubes, and then we did the grouping method. Okay, so there was actually another method that we did go over. What was the other way to factor things? That's part of factoring quadratics. So quadratics is easy method and hard method. What's another method to use that factors? Did the video play at all?
It did, but it didn't make sense.
What did they use in the video? Synthetic division. Okay, synthetic division allows you to factor. Did that sink in? Okay. All right. So let's say I take number 1, and let's say I didn't notice that I could do the grouping method, or maybe I don't remember how to do the grouping method. And so what I'm going to do is I'm going to use synthetic division in order to factor this. Okay. So over here on the side I'm going to talk about a couple things, and hopefully you wrote this down, but if you didn't, write this down now. Okay, they talked about something called the rational root theorem.
Yeah.
Okay, so here's the idea behind the rational root theorem. Okay, let's say we have some polynomial, we'll call it p of x. Okay, and it starts out as ax to the fifth plus bx to the fourth plus blah 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 all the way back to the constant. Okay, so the idea of the rational root theorem, ooh, hold on, let's go back a little bit. I feel like we need to talk about this. Before I go further, what does the word rational mean? Okay, so let's go back to Algebra 101. Okay,
Yeah, please.
so way back when there was cavemen walking the earth, they invented numbers. Okay, and the first numbers that they invented were natural numbers. What were those numbers? 1, 2, 3. Okay, the ability to count. Counting numbers. Okay, then they got a little smarter and they added one more number. And the next category is called whole numbers. And what's the one number they add to whole numbers? 0. So you got 0, 1, 2, 3, 4. Okay, then people get a little bit smarter and now they start including negative numbers. So we have negative numbers and positive numbers, which are called integers. Okay, so we got negatives and positive. Then we get a little smarter. What's the next set of numbers they invent? Fractions, which are called rational numbers. Okay, so a rational number is any number that you can write as a fraction. Do you want me to write that down? Any number you can write as a fraction. Okay, as opposed to irrational numbers, which are numbers that you cannot write as fractions, such as the square root of 2, the square root of 5, pi. Okay. All right, so rational, ooh, what does the word root mean? What do they mean by a root? Anybody know what a root is?
Like the base.
Seems like yeah. No, it's not a base, but that seems like a logical thing. A root is a fancy word for a 0. Okay, so we've talked about zeros. What is a 0?
Nothing.
What?
Nothing.
Nothing? No, it's where it crosses the x-axis. Where the function crosses the x-axis. Okay, so what we're looking for here with the rational root theorem is numbers that we can write as fraction where it crosses the x-axis. Okay, and why would that be important information for us to know? Why do we care about zeros or roots? It allows us to solve equations. It's the solution when we set it equal to 0. Super important. Okay, so anyways, the rational root theorem says you take the constant, which in this case I labeled as c, and you divide it by the leading coefficient. So it's my very first number, a. Okay, and what you're going to do is you're going to list all of the factors of c over all the factors of a. Okay, so an example of this idea. Let's say we have 4x to the fifth plus 3x to the who cares plus 2x to the even who cares more minus 8. Okay, and they asked me to, they would say, list all possible rational roots. Okay, so to list your possible rational roots, you use the rational root theorem. Okay, so in my case, what is the constant value? -8. So very one at the end, -8. And I really don't care if it's a positive or a minus. We're just going to say 8 for the most part. Okay, what's the leading coefficient? 4. Okay, so then what I'm going to do is I'm going to list all of the factors. Okay, so what are all the factors of 8?
1, 2, 4.
1, 2, 4, and 8. Okay, and what are the factors of 4?
1, 2, 4.
1, 2, 4. So this is kind of like a thought bubble, really. Okay, so if I'm going to list all of the combinations between this, I'm going to do 1 over 1, 2 over 1, 4 over 1, 8 over 1. Okay, then I'm going to do all the factors over 2. 1 over 2, 2 over 2,
Which is 1, so 1.
4 over 2, 8 over 2. Everybody see what I'm doing here? All of those combinations. 1 over 4, 2 over 4, 4 over 4, and 8 over 4. So Connor immediately noticed that we do have some that repeat. Okay, so all of the possible rational roots would be the reduced versions of all these numbers I just wrote. So 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 8 over 1 is 8, 1/2. Now 2 halves is the same as 1, which I wrote already, so I don't have to repeat that. 4 halves I wrote. 8 halves is 4, did that. So then I have 1/4, 2/4, 1/2, I've got that. 4/4, that's 1, and 8/4 is 2. So then I would also have all of their negative versions as well. Okay, so here is the idea of this. So whoever invented this theorem, he didn't name it after himself, so we're going to call him Bob. So Bob noticed this little pattern, okay, and he said, okay, well, here are my possible rational roots. So now what I can do, so let's say I have, so I'm trying to find the roots of this equation, right? Okay, so what I would do is I would take one of those possible rational roots, and I would plug it into my box and do synthetic division until I came up with a remainder of what?
0.
Of 0. Okay, so I'd pick one of those. So which one do you want to pick? 2. So I'd say, okay, let's try 2. And I'd put that in the box. And I'd cross my fingers. Whoops, that should be a positive 2. And maybe say some prayers. And hope that 2 happens to be a remainder, because otherwise I have a whole lot of numbers to check next. What's that? Yeah, just one of those possible numbers, just one of them. Okay, so do you think that this would be very efficient for us to use nowadays?
No.
I mean, gosh, thank goodness for technology, right? Okay, so back then they didn't have calculators. But we have calculators now. Okay, so we can now take this equation and type it into the calculator and see where it does actually cross in order to narrow down those possible roots. Okay, so since I made this equation up, I'm not going to do this example because it's possibly likely that there's not a rational root, because I just totally made that up. So we're going to scratch this example and stop for a second, and I'm going to do, go back to number 1, the one we were doing. Okay, so we're going to do number 1 with the idea of using the calculator to narrow down our possible rational roots. Okay, all right, so I'm going to start by plugging that into the y equals. So I have 4 x to the third plus x squared minus 4x minus 1. Okay, and I know that since we're typing in x to the fourth, or excuse me, 4x to the third, I know what this is going to look like, right? Anything to the third is going to look like a John Travolta. So I'm looking at this going, oh, yep, that's a John Travolta. And I can see that it crosses the x-axis 3 times. So I have 3 solutions that I can find. So what is one of the places where it crosses the x-axis? Ooh, do we know how to check to see that with the calculator? Sounds like nobody's positive. You guys are kind of like, So, we can do the table, or we can do trace. So if you hit second trace, and make sure everybody knows how to do this, because you need to be able to do this on a test. Okay, we would choose number 2. We're looking for a 0. Okay, so let's say we're going to find that one on the far right. That looks like 1-ish. Okay, so if I put my cursor pretty close to that spot and say, okay, it's asking me to go to the left of it. If I push left twice, I know that I'm on the left of it. And notice that when I'm on the left of it, in this scenario, I go below. So now it says go to the right. So I'm going to push the right button until I'm to the right of it, which will take me above. Okay, and then I hit enter, and I should see 2 arrows pointing at each other, which is a little hard to see, but they're pointing at each other. And for the guess, I can just hit enter as long as those are pointing at each other. So did anybody else get a 0 of 1? Good? Okay.
I got negative 0.25.
Negative 0.25. Oh, okay. I'm not disagreeing with that, because you found the 1 in the middle. Yes.
If I did do the same equation, I got an error.
Then probably you went to the right and then to the left. Or you typed the equation in wrong. Is it graphing it?
Yeah.
Okay, then I'm guessing you went backwards. Okay, so we are going to now use synthetic division in order to factor this. So the number we just found is 1. So I put 1 into the box, and I'm going to use synthetic division here. So what are the numbers that follow? So going back to the original polynomial, 4, 4, 1, negative 4, negative 1. Okay, so I dropped the 4, and 4 times 1 is 4, and 1 plus 4 is 5, and 5 times 1 is 5, and negative 4 plus 5 is 1, and 1 times 1 is 1, and so I get a remainder of 0. Now I always get into the habit of just putting the last number in like a box, so I know that that's the remainder, and so on the next step I'm not going to use it. Okay, so by getting a remainder of 0, I just proved that 1 is a solution to this equation. It is in fact a 0. Okay.
How would you do that with a fraction?
A fraction?
You do it like the same way.
Oh yeah. Okay, so what is another place where we cross the x-axis on our function? So Emily, you said you got negative 0.25, right? Okay, so let's use that. What is negative 0.25 as a fraction? Negative 1/4. So let's use that. So we got negative 1/4. Okay, now notice that I'm using the numbers from the next row to keep breaking. Every time I do synthetic division, I'm factoring it further and further and further. Okay, so if I drop the 4, what is 4 times negative 1/4? Negative 1. Okay, what is 5 plus negative 1? 4. 4. What is 4 times negative 1/4?
-1.
And so I get a remainder
0.
of 0. Okay, so at this point, I am down to a linear polynomial. What is my linear polynomial here? 4x plus 4. Okay, so to find my third 0, I'm just going to set this last quantity equal to 0. So how would I solve that?
Subtract 4 divided by 4.
Subtract 4, divide by 4. So negative 4 divided by 4 is? Negative 1. So do you see the answers that I just found? Negative 1, negative 1/4, and positive 1.
Okay, why did you put it like 4x? Like, why didn't you just solve it?
4x plus 4. So are we talking about right here? Yeah, why did I put that? Because I'm down to a linear quantity, and I can solve linear quantities. So this just becomes 4x plus 4, and I can set that equal to 0, and that's very simple.
It's like the one that you started with, the 4, 1, negative 1, is what is above without all the x's.
So this one is representing that polynomial.
So you just put the x's back in the dash.
This one right here would be 4x squared plus 5x plus 1. So I could actually have stopped here and factored this using the hard method. That would have been an option. Okay, but I kind of like to do synthetic division if I'm in the middle of synthetic division.
That's the check. Yeah.
What's that?
Is that more the check your answer or?
Well, it would be, I would
I mean,
say
you wouldn't know
you would
about
do
the
one or
1/4.
the other. I would say you could do this by factoring it and doing it the grouping way, or you can do it by factoring it using synthetic division. I would not do both. I mean, you can, and that would check it, but
Someone you wouldn't know about the 1/4 stuff.
yeah, you have to use that last linear quantity to get that. Okay, so how did we do on question number 2? Okay, so this is asking us to solve this equation by factoring. So we can factor it by using synthetic division, or we can factor this by just methods that we already know. So if you look at that, is there a method you could use to factor that? What is always the very first thing you should try? Do we have a greatest common factor here? X cubed. So this is actually a really interesting scenario. So if I factor this and said x cubed, what would be left over? X squared minus 2x minus 24. Now, can I factor x squared minus 2x minus 0 further? Okay, that would be easy method. Are there two numbers that multiply to negative 24 and add to negative 2? Kinda, yeah. Which one's positive, which one's negative? Negative 6, positive 4. So I could just factor this one using old methods. So would we all agree the solution for this one would be, if I set x cubed equal to 0, I get 0. If I set x minus 6 equal to 0, 6. And if I get x plus 4 equal to 0, I get negative 4.
Why is x like cubed equal to 0?
Why is it equal to 0? Because that's how you solve once you factored it. You set each of the quantities equal to 0.
But it just equals 0.
Well, yeah, because 0 cubed is 0. 0 times 0 times 0. So what if we were to do this one by using synthetic division? Okay, check this out. This is kind of an interesting thing. I'm going to use Desmos, if that's all right with you guys. You guys can use Desmos too in this section. The thing I really like about Desmos is it's super easy to find the zeros. The only thing is that you can't use Desmos on a test or a quiz, so you need to still be efficient at the calculators. Okay, so if you are struggling with using a calculator, make sure you ask me. Otherwise, I'm assuming that everybody's okay with finding zeros. Is that a fair assumption? Okay, so can somebody read me number 2? It x to the
X to the
fifth
minus 2x to the fourth
2x to the fourth.
minus 24x.
Okay, so this is really interesting. So we see this John Travolta, and we can see the 3 zeros that we found. Okay, now watch what happens when I do synthetic division. Are you ready for this? I'm going to do this kind of quick, so make sure you're paying attention. You don't have to do this, but just watch. Okay, give me one of the zeros that I'm going to use to break down my
0.
quintic piece. You want to start with 0?
Sure.
Okay, so for number 2, let's use red. Okay, I would put 0 into the box. What are the numbers that follow from my x to the 5th minus 2x to the 4th minus 24x cubed?
1, -2, -24.
And what keeps going after that? Remember that I have to have a placeholder for every term. So how many x squares are there? How many x's are there? How many constants? 0.
Huh.
Okay, so if I break this down, drop the 1, 1 times 0,
0.
-2 plus 0
0. Oh, sorry,
is -2. -2 times 0 is 0. -24 plus 0 is -24. 0, now we get 0, 0. So the last number is my remainder of 0. Okay, so 0 worked. Okay, give me another 0 I can use. -4. All right, so now I'm going to use -4 in the box and keep breaking further. Okay, so I drop the 1. 1 times 4,
4.
-2 plus 4.
2.
2 times 4.
8.
Oh, my bad. Sorry, -4. Hold on, my bad. You said -4, I wrote 4. -2 plus -4. -6. -6 times -4. -24. -24. Positive. Good Lord, I got this. 0 times -4. And 0, 0, 0. So the last number is 0. Okay, what's the last root that I can use here? 6. Okay, so 6. 6 goes in the box. So I drop the 1. 1 times 6. -6 plus 6. 0, 0, 0, 0. So what is the polynomial that is left right here? 1x to the... Okay, so remember, the first one, my first polynomial was to the 5th, right? So this one's to the 4th, this one's cubed, so this one is squared. So the piece that is left is x squared. So if I said x squared equal to 0, would everybody agree that x squared is the same as x times x? So x can be 0 or x can be 0. See what I mean by that? It's like using this x and then using that x. So see how many solutions I just found? How many solutions did I just find? There's 2, 3, 4, 5. How many of them were 0? 3. Do I have to list the 0 3 different times when I state my solution for number 2? Technically, I do not have to. Okay, but I think that it's a valuable piece of understanding. Okay, so when we factored this, see how I had an x cubed out? Whoa, I almost tripped. X cubed right here. How many x's are there? 3. So this is actually hitting 0 3 times. So you guys remember when we were graphing polynomials? And we had quantities that were squared and quantities that had odd exponents, so even odd exponents versus odd. Do you remember the difference in those? What happened at even exponents? Not crossed. They bounced. Okay, so you start to see things that bounce. So if I see a function that bounces, that means there's 2 zeros there. If I see one that crossed, I have an odd exponent. So it could be x to the first, x to the third, x to the fifth, x to the seventh. I could potentially have more than 1 0 there. Okay, so in this case where I have this function, this crosses 0 like 3 times. See how it does that little wiggle? That's because I have x cubed right there. Okay. All right, so can you do number 3 and number 4 on your own?
Number 3.
Number 3 does not make sense. Okay, so 3 and 4, I'm going to say you can use whatever method you want to factor this. Okay, you can decide to do greatest common factor and then factor it doing easy or hard method, or you can use synthetic division to break them all down. So which method should we do? For number 3? Okay, so we're going to do greatest common factor for number 3. So what is the greatest common factor for number 3? 3x cubed. Okay, if I pull out 3x cubed, what's left over?
X squared plus 6x plus 6.
6x minus 7. Okay, so now on that quadratic term, can I factor that further? What two numbers multiply to negative 7 and add to 6? Numbers that multiply to negative 7 add to 6. Close. Negative 1, positive 7. Okay, so what are the 3 solutions that I get here? What do I get if I set 3x cubed equal to 0? 0. How many zeros are technically there? There's 3 of them. What do I get from x minus 1? 1. And what do I get from x plus 7? Negative 7. Okay. So number 4, I would suggest doing the exact same method. Pull out a greatest common factor and then factor that. Yes. Number 4?
Yeah, we should definitely.
Oh, we should do that one? Okay, so let's do that one. What did you pull out as your greatest common factor?
X squared.
X squared. So if I pull out x squared, what's left? Okay, let's do this. Anytime your first term is negative, see how there's a minus x to the 4th? We're going to pull a greatest common factor of a negative. So because the first term is negative. Anytime the first term is a negative, you pull out a greatest common factor of a negative, because when we're factoring quadratics, we don't want an x squared that's negative. That will screw things up. Okay, so then I'll be left with x squared minus 2x minus 8. How about that? Is that easier to factor? So what two numbers multiply to negative 8 and add to negative 2? Negative 4, positive 2. So what are our solutions? 0, 4, negative 2. And how many zeros are there, by the way? 2 of them, right? So what's going to happen if I graph this one? What happens at 0? If it has an even exponent. Is it going to cross or bounce? It's going to bounce, okay? So you can see if you graph this equation, it's going to bounce at 0, and it's going to cross through at 4 and negative 2. Okay. Okay, so let's talk about 5 and 6. I'm not going to do both of them. I will do one of them, and I'm going to actually choose 6 because number 6 has to be done by using synthetic method. There is no other way to do it. Okay, so number 6. I'm gonna do this way over here. So can somebody read me number 6 since I can't see it now?
X cubed
X cubed
plus 5x squared
5x squared.
minus 8x minus 48.
Aaron, did you ask a question that I should answer?
Yeah, how do you know that?
Oh, how do I know? Okay, so the methods that we all know. Okay, there's quadratics, which require easy method, hard method, and we can do quadratic formula, but we can't do a quadratic one yet because it's a cubic. So the only methods we know to do cubic are grouping. So I could group the first two and group the last two, but if I think about this for a second, like think about the greatest common factor for this one, it would be x squared, and I'd be left with x plus 5. And for this one, I would not be left with x plus 5. Because 48 is not multiple 5. So that's how I knew that, just by looking. I mean, you could try it and see, but it wouldn't work. Number 5. So this one actually has to be done using synthetic too. You cannot do grouping method because again, x squared is your greatest common factor and you're left with x plus 1. You'll be left with 3x plus 1 now, which is opposite. So both of them you have to do synthetic division on. Okay, so how do I go about doing this?
Factorable constant.
Okay, we're not going to do that. We're going to use our awesome technology so we don't have to just do a guess and check. So we're going to start by plugging this into the calculator.
Can you show us how
Okay.
to find the zeros on the calculator?
On a calculator? Sure.
Yeah.
Fine. I just like to use Desmos though. Okay, so I do x to the 3rd. Okay, so hit graph. Okay, so looking at this, they look pretty dang nice. Like 3 looks beautiful, and the other one looks like -4. So if you were going to find the 0 of -4, you can't find it as a 0. You have to find it as a maximum because it's the top of that peak and it doesn't cross. Do you guys see what I'm saying by that? See how -4 is different? The calculator won't interpret that as a 0 because it doesn't cross through, it just touches. So if you're going to find a 0, you hit second trace, and we're going to do number 2, and we have to find the one on the right. Okay, so I'm going to arrow to the right until I can see my cursor. I can see that if I look at the x value right now, I'm at 1, which if I look at that, that's actually kind of a good way to make sure I'm to the left of 3. Because 1 is to the left of 3, right? It's less than. So if I hit enter, I'm okay. And then I'll just watch that x value until I'm on the right of it. So what value is to the right of 3? 4. Sure, let's just go until my x says 4. That looks good. Hit enter. Okay, see the 2 arrows are pointing at each other? Okay, once those are pointing at each other, I can just hit enter, and I get an x value of 3. Did you get it? Uh-oh, what happened to my stuff? Whoa, that's weird. It disappeared. Whoa. Weird. Okay, so 3. Can I go ahead and keep going? Chan, are you okay?
Yeah.
Okay, so 3 goes into the box. What are the numbers that follow?
Oh, 1, 5,
1,
-8.
5, -8, -48. Okay, so I drop the 1. 1 times 3?
3.
5 plus 3? 8 times 3?
No.
24? -8 plus 24? 16 times 3. Negative 48 plus 48. Boom. So what is the polynomial that I have at this point? What is 1, 8, and 16? So it gives me x squared plus 8x plus 16. Could we factor that using the easy method? Are there two numbers that multiply to 16 and add to 8? 4 and 4, right?
So really the synthetic part of this method is just a starting point.
Yeah. Okay, so once I get to quadratic pieces, I know how to factor quadratics. Okay, so I can use that. What is the quantity that I would need in order to make a 3? So if I have a 0 of 3, yeah, x minus 3. So did you notice in the directions up here it says factored form? It says identify the zeros and then write the function in factored form. Okay, so we're factoring this, not solving it. So we should write this as x plus 4 times x plus 4. If you want to write x plus 4 squared, go for it. And x minus 3. So this is our factored form of our function. Okay. No, because you're factoring it, you're not solving it. See how it says f of x equals, as opposed to the ones above, equals 0? So those are solving. Okay, so are we okay with how to factor by using synthetic division? Good. Okay, what about, should I do one of 7 or 8? So I really don't like the way they wrote this instruction. It says identify all the rational roots of each equation. That just basically says solve, and all of the answers should be rational. Okay, so why don't we do number 8 together, since I just got some funny looks. Okay, let me pull this over right here. Can somebody read me number 8, what it says?
X cubed plus 10x to x 47x.
Okay, so if I'm going to solve a polynomial, what is the first thing I always have to do? Set it to 0. Same thing with quadratics. It is no different with a polynomial. I have to set it equal to 0 before I can do anything. So I'm going to subtract the 10 over. Okay, and I'm just solving this. So how am I going to solve this? What do I do?
Oh, I thought that was where you just needed the factor. Like negative 10.
Huh?
Like the negative 10 over 3 and then find all the...
Oh, all the rational roots? So
Yeah.
you're going to test all of them?
No, it's not that.
We don't have to do that. We can use our awesome technology to kind of bypass that step.
So we actually are solving this then, we're not just doing.
Yeah, we're solving this.
Yeah, because it says just, oh my goodness.
Solving by using, so it just says your roots are going to be rational, which means they're going to be possibly written as a fraction. Okay, so I type this into the equation, not the equation, type this into the calculator. Okay, so I'm looking for where this crosses the x-axis. Okay, how many solutions do you see? 3. Okay, so that means if I can see that there's 3, then I better have 3 answers. What does one of them look like? I think I disagree with that. It looks slightly to the left. How about 2? Yeah. So let's try 2. I'm not even going to test it in the thing. I'm just going to do synthetic division to prove it. So I have 3, 10, negative 27, and negative 10. Maybe I'm wrong, but it's wouldn't be the first time. So I dropped the 3. What's 3 times 2? 10 plus 6? 16 times 2. Negative 27 plus 32. 5 times 2. Remainder? 0. So did 2 work? Awesome. Alright, so right now I have 3x squared plus 16x plus 5. Okay, I have a quadratic, and I could use the hard method to factor that, or I can use synthetic division to factor it. So why don't we use synthetic division this time? Where is another nice 0 that you can see on the calculator? Negative 5? Alright, Connor says negative 5. Let's see if he's right. Negative 5. Okay, so I drop the 3. What's 3 times negative 5? Negative 15. 16 plus negative 15? 1 times negative 5? Remainder? Nice. So what is the last piece I have here? What's my polynomial here? My linear. Good. 3x plus 1. If I set that equal to 0, I will find my third solution. What's my third solution? Negative 1/3. So I found solutions of negative 1/3, negative 5, and 2 for question number 8. Awesome. So you're good with number 7 then? What did I have? 2 and negative 5. What do you guys think about number 9? Because it has words.
Words is scary.
Oh, it's pretty easy.
English.
So you got it? Think so? Okay. Does anybody else want me to do this one?
Yeah.
I actually want to do this one for a reason, because today I did plan to do 7-2, and 7-2 is exactly the same as 7-1, except for you get irrational solutions as well. Okay, so number 9 actually plays straight into this. It's not a big difference between what we're doing. So let's do number 9, and then I don't have to give you any notes for 7-2. How's that sound? It's like 2 birds with 1 stone. I still will give you the worksheet. We'll do one of them together, make sure you got it. And then I'll give you a few problems on the worksheet. And we'll finish the rest Friday. Alright, so number 9 says we've got this engineer who is building a storage compartment in a spacecraft. Cool. The compartment must be 2 meters longer than it is wide, and its depth must be 1 meter less than its width. So we're going to find the volume. Oh no, the volume is gonna be 8 cubic meters. So yeah, so let's start with what the shape is of this compartment. Rectangular prism, although box is also descriptive. So how do you find the volume of a rectangular box? Okay, good. So length times width times height. Now, what I'm going to do is I'm going to replace length and width and height by the words they use in this. So they say longer than the width, so that would be a length. They talk about a width, but they also use the word depth. So we'll say the depth is our height. So we'll use D for depth. Fair enough? Okay. So they say the volume has to be 8. So we'll say 8 equals. Okay, what is my L gonna be? L says 2 meters longer than the width. W plus 2, very good. W plus 2. The width is the width, so what do we use for width? W. And the depth must be 1 meter less than the width. W minus 1. Show. Yeah, like 3 of them, right? So we've got this cubic. So the first thing that I notice is this is written in, well, it's not even written in any form. It's nothing, because it's not set equal to 0, and it's not, it's like kind of partially factored, but not correctly. So what we need to do is we need to start by writing this in standard form. So how would I put this into standard form? Multiply it all out, okay? So down below I'm going to kind of play with this. So I'm going to start by distributing this w. I'll just throw it through the second quantity if that's right. So I have w plus 2. I'm not going to touch that. What's w times w? W squared. And what's w times negative 1? Negative w. So then I have to FOIL this. So what's w times w squared? W cubed. What's w times negative w? And 2 times w squared? 2w squared. And what's 2 times negative w? Negative 2w. So is it okay if I combine like terms and then also subtract the 8 all over in one step? You guys good with that? So I get w cubed, then I'll get plus w squared minus 2w minus 8. Good there? So here is the equation that I have to solve. Okay. B says list all possible rational roots. How do I list possible rational roots? What theorem do I have to use? The rational root theorem. Okay, so let's do B here. Okay, so they specifically ask us to list the possible rational roots. So I need to do my constant, which is what? Negative 8, so I'm just going to use 8. And what's my leading coefficient? 1. Okay, so my little thought bubble is, what are all the factors of 8? 1, 2, 4, 8. And since all of these are over, the factors of 1, which is 1, my possible roots are going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So one of those is going to be my answer here. 8 possibilities. So how can I go ahead and narrow this down very quickly and solve this equation? What? Graph it. Okay, so we're going to graph it and see which of those it is. So I'm going to type in my equation. I'm going to use an x rather than a w. X to the third plus x squared minus 2x minus 8. Okay, so when I hit graph, which of those rational roots does it look like it crosses? 2. Everybody see 2? So what do I do with the value of 2? Put it in the box, right? So I go 2. What are the numbers that are going to follow? 1, 1, negative 2, negative 8. So I drop the 1, and that gives me 1. And then 1 times 2 is 2, and 1 plus 2 is 3. And 3 times 2 is 6. Negative 2 plus 6 is 4, and 4 times 2 is, whoa! Where did I go? Oh, there it is. Excuse me, 8. So I get a remainder of 0. So at this point, what is the quadratic that is left? Plus 3x plus 4. Okay, can I factor that using easy method? Are there 2 numbers that multiply to 4 and add to negative 3?
Yes.
Positive 3. No. So how could I possibly solve this quadratic equation if I couldn't factor it? What? No. You mean like the hard method? It's not factorable. So what methods do we know to solve quadratics that are not factorable? The quadratic equation. Well, quadratic formula, yeah. Okay, so check this out. If I do the quadratic formula for this, negative b, what's my negative b? Negative 3 plus or minus the square root of 3 squared minus 4 times the a times the c all over 2 times the a. So I get negative 3 plus or minus, let's see, I got 9 minus 16 on the inside. What's 9 minus 16? Negative 7. So when I get a negative underneath the square root, what kind of solution am I finding? Imaginary solutions. So check this out. What's happening here is I'm finding a solution to our equation, that initial polynomial, but it's an imaginary solution, which is why we do not see it on the graph. Imaginary solutions will not show. Okay, but we can use quadratic formula to find the rest of our solutions. Okay, so since we are talking about non-imaginary scenarios and we're building a box, what is our width going to be? We're going to use 2. We're going to use a real length. We're not going to get out a ruler and measure out an imaginary length. Even if we are NASA, we still need real numbers. So, see, it says use synthetic division to find the roots of the polynomial. Are all the roots rational numbers? No. So what we found was no. We had one rational root. And then what else did we find? 2 imaginary. Okay, so it's possible you could find 2 irrational, like you could get something like a square root of 2 plus or minus the square root of 2. So what are the dimensions of my storage compartment? Remember that it did, so I have w plus 2 for my length, so 2 plus 2, 4, so I have 4 by my width, which is 2, by my depth, which is w minus 1, by 1. So 4 by 2 by 1, and we're talking about meters, so I better label meters. 4 meters. Yeah, it seems pretty big. Maybe that's somebody's bed. Okay, so does this idea of being able to solve all polynomials, including non-rational numbers, make sense? Okay. So what I'm going to do is I'm going to give you the 7-2 worksheet, and you're going to do 4 problems for homework. What's that? Yeah, you have finished. So your assignment is to finish the 7-1 assignment. And then I'm going to give you 4 problems from the 7-2 assignment. So yeah, so start here. Use that one. I'm gonna do one question on here. Okay, so what I want you to do on the 7-2 worksheet is I want you to do 5, 6, 7, and 8 on the AB side. So on the AB side, I want you to do 5, 6, 7, and 8. Okay, so I'm going to do number 5 with you and make sure we got this, and then I'll give you the last 3 to do on your own. Okay. Yep, 5, 6, 7, and 8. So you might need a separate sheet of paper to show your work, by the way. Okay, so we are solving. Notice the directions say to solve, and we're going to find all of the roots. Okay, now when I look at number 5, how many roots is this going to have? How many solutions am I finding? 4. Do you see where I get 4 from? 4. So that means I'm going to find 4 solutions. Okay, so where do I start? Sorry, I don't know why that's like picking up the drag. That looks really sloppy. Okay. So what do I do? Uh-oh. Can I give you a hint? Graph it. Start by graphing it. Okay, use the calculator, and we're going to use synthetic division in order to factor all these and solve them. Okay, so I got x to the 4th minus 2x to the 3rd minus 14x squared. Whoa, 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 whoa. I think my tablet is like overheating. It's not, because now it's having a hard time processing. Okay, so we should get some kind of parabolic looking thing because it's an x to the 4th, and I can immediately see I have a parabola here. I see 2 real solutions, which tells me what? There's 2 imaginary solutions, okay? Imaginary meaning I can't visually see where they cross the x-axis. Okay, so give me one of those real ones. Where does it cross? 1, 2, 3, 4. Negative 3 and 5. Okay, so let's start with negative 3. So I'm going to put negative 3 into the box. We got 1, negative 2, negative 14, negative 2, negative 15. Okay, so I drop the 1. What's 1 times negative 3? Negative 2 plus negative 3?
Negative 5.
Negative 5 times negative 3. Negative 14 plus 15. 1 times negative 3. Negative 2 plus negative 3. And negative 5 times negative 3. So remainder? Beautiful. So negative 3 is definitely a solution to our equation. Now let's use our other 0, which you said was 5, right? we're going to use 5. Notice that I'm using the broken down polynomial. Do not go back to the original. Okay. So I drop the 1. 1 times 5.
One, or
Negative 5 plus 5.
zero,
0 times 5.
Zero.
0,
1 plus 0.
1,
1 times 5.
5.
And negative 5 plus 5. There we go. Alright, so what is left here? I have 3 numbers. By the way, 3 numbers always tells me I have a quadratic. So what's my quadratic here? X squared plus 1. Ooh, I like it. I like it a lot because I don't even need to use quadratic formula to solve this. I can just solve this algebraically by isolating the x. So how would I isolate the x here? Minus 1. Then what? Whoops. And square root. So what is the square root of negative 1? I. And don't forget, if you solve an equation and you take a square root, you get plus or minus I. Yes. From this one? Okay, so remember how every time I do synthetic division, I lose an x? So this is to the 4th. So this one would be x cubed. So this one's x squared. Alright, so what are my 4 solutions to number 5? 5,
5, negative 3, and
negative 3, and I, and negative I. Which you can write as plus or minus I, but I'm just writing it separately because not everybody remembers that those are 2 different numbers. Pretty good?
So they have to do 4 on this.
So, yep, you only have to do 4. I'll give you the rest of them on Friday to finish. Okay. I do have a review, but it's a short review. It's just a Module 7 review, so it's nothing new. Yep.